Hello, this video is on section 6.3, which is titled Proving that a Quadrilateral is a Parallelogram, and the learning target is to determine whether a quadrilateral is a parallelogram. So this section is almost identical to 6.2, however it's a little bit backwards of a thought process. We're still discussing some of the theorems on parallelograms and talking about the sides and the angles and the diagonals. However, instead of assuming that this figure is going to be a parallelogram, now you're going to have to prove that it is a parallelogram given certain conditions. So the theorems that I had listed on 6.2 are basically the exact same thing as these five that I've listed here. However, now all of them are in conditional statements. Or they're in if-then statements, so all of these have an if and a then. So your hypothesis and conclusion for all of these theorems are if the opposite sides are congruent, then it is a parallelogram. If the opposite angles are congruent, then it is a parallelogram. If consecutive angles are supplementary, then it is a parallelogram. If the opposite sides are parallel, then it's a parallelogram. If the diagonals bisect each other, then it is a parallelogram. So you should be getting more familiar with these as we're still working on them. But now it's a little bit backwards where you're given a quadrilateral and you're trying to prove that it is a parallelogram by saying, hey, maybe these opposite sides are congruent, then it's probably going to be a parallelogram. Hey, maybe these diagonals bisect each other, then it's going to be a parallelogram. So we'll go through some examples in class on how this is the case, but the problems are going to look very, very similar to what you've seen before in the past.